Okay, so for type 2 binary ionic compounds, these contain a metal and a nonmetal, and so there's two types of elements, but in this case, our metals can have more than one possible charge, and so it's going to be important that when we name these compounds, we in some way distinguish between the two possibilities. Okay? So most of these type 2 metals are transition metals, but there are some examples such as tin and lead that also fall under the type 2 category. Okay, so in this case, it's going to be important for us to figure out what is the charge of the ion that we are describing so that we can name it appropriately. So with these metals, with type 1 metals, there's only one possible charge, so we don't need to have any special rules. We can simply name the cation and then the anion. But in the case of most of our transition metals, we need to indicate whether it's a +2 or a +3 or a +6 charge. Okay. Now, as a side note, these type 1 metals typically are our main group metals, but there are also a couple of very common examples such as silver and zinc that fall into this category. So silver and zinc are both transition metals, but they have only one possible charge, and so they fall under the type 1 rules. Tin and also lead are not transition metals, but they have more than one possible charge. We can have a tin with a +2 charge and also a tin with a +4 charge, and these would form distinct compounds, such as if we bring together tin 2+ with chlorine, we would get SnCl2. If we had a +4 tin, that would give us a formula of SnCl2. So we can't simply call this compound tin chloride because that name does not distinguish between these two possibilities. Now, there are many of these type 2 metals are very common, and we're going to talk about the different rules that we use, but we'll have things like iron and copper and cobalt and tin, lead, and mercury that all have more than one charge. And again, notice a lot of these are transition metals, but tin and lead are sort of exceptions to that idea. Now, when we name type 2 compounds, the first thing we need to do is figure out the charge. And we're going to do this by associating the charge of that metal with the charge of our anion in the compound. Okay, so for example, if we look at this compound, we have Au, which is gold, and S, which is sulfur. So Au2S3. So in this compound, we know that sulfur, being a group 6A, right under oxygen, will tend to form -2 ions. In fact, all of the sulfur containing binary compounds, that sulfide rather, has a -2 charge. So knowing that sulfur is a -2, and there are 3 of them, this tells us that there is a total of -6 negative charge. That Since this is an ionic compound and it has a net neutral charge, that means the total positive charge has to be +6 to balance this. So in those two golds, there is a total of +6 charge, telling us that each gold has a +3 charge. And so from our formula Au2S3, we can now name the cation followed by the anion, and in naming this cation we are going to indicate the charge using Roman numerals. So we will call this gold 3, and we'll use a Roman numeral to indicate that 3 sulfide. Okay. Okay, here's a couple other examples. Okay, again, we indicate the charge on our cation by Roman numerals, and this distinguishes between any other possible compound. So here we have CuCl. We know that chloride has a -1 charge, and that tells us that this copper ion must be a +1 charge. And so we are going to name that ion simply by naming the metal followed by a Roman numeral indicating its charge. So with a +1 charge, this is Cu plus and Cl minus, we will name this copper 1 chloride. Oops. Here in our HgO, Hg is mercury. Again, it's a transition metal that can have more than one possible charge. Okay, so we're going to figure out this charge, recognizing that the oxide here will always have a -2 charge in our binary compounds, and therefore mercury must be a +2. So we'll name this mercury 2 oxide. Okay, always writing the cation followed by the anion, and when we have these type 2 metals, we must indicate the charge with a Roman numeral. We never use a Roman numeral for our type 1 binary compounds. In fact, we don't use these Roman numerals for anything other than these type 2 metals that can have more than one possible charge. Okay, so in our naming scheme, again, we're going to identify if this is a binary compound. Once we have said, yes, this is a binary compound, there are only two types of elements. We ask, is a metal present? If there is not a metal present, we are going to use our type 3 rules. But if there is a metal, we got to distinguish between type 1 metals, which only have one possible charge and are therefore very simple. Name the cation and then the anion. If it is a type 2 metal with more than one possible charge, we must indicate the charge using Roman numerals. Now, this is what we call the systematic or IUPAC convention, and is the more modern approach to naming these type 2 binary compounds. However, there is also a very commonly used system that I call the classical system. And I'm going to scroll back up to this table and give us some examples. Okay, so our systematic name for naming these ions, like iron Fe3 plus, we call iron 3. Fe2 plus we call iron 2, Cu2 plus we call copper 2, and Cu plus is copper 1. Right? So the Roman numeral indicates the charge there. However, it is perhaps more common to see these ions named using their classical system. Okay, so in this classical system, which is a little more difficult to remember, we indicate the ion. When there are two possible ions, we indicate the one with the larger positive charge with an IC ending, using the root of the element, usually the Latin root, followed by an IC ending. So Fe3 plus, which would be called iron 3 in our systematic name, we call this the ferric ion. Whereas iron 2 we call the ferrous ion. So the OUS indicates it has a lower oxidation state or a lower positive charge. Similarly, copper 2 is called cupric and copper 1 is called cuprous. Right? And so you can see from this list that there are a variety of these that are very commonly used. Stannic and stannous, plumbic and plumbus for lead, mercuric and mercurous for mercury. Now, I do not expect you to memorize all of these, but the ones that I've boxed here, iron and copper, are so common that it's important that you can name compounds containing iron using both the systematic approach as well as this classical approach. And let's just give two examples with iron and copper. So iron can form two different ionic compounds with chlorine. Okay, we can have FeCl3 and FeCl2. Now, these are unique compounds, and we need to come up with a unique name for them. So the first one, in our classical name, we would determine that the charge on that iron is +3 because there are 3 chlorides. Remember, chloride always has a -1 charge. And so we would name this in our systematic name, iron 3 chloride, whereas we would call FeCl2 We would call that iron 2 chloride. Okay. In our classical name, we call the iron 3 ion, we call that the ferric ion. So it is actually more common for this FeCl3, excuse me, to be called ferric chloride, and FeCl2 we would call ferrous chloride. Okay, and so these are so common that it's important for us to know both the classical and systematic names for iron and copper. Okay, so for example, if we saw the name cupric sulfide, right, we would know that that IC ending indicates the higher oxidation state, which in the case of copper is our +2 ion. And so we would know that this formula, knowing that sulfide is a -2 ion, this would have the formula of CuS.